Hi everyone, welcome back to Code Data channel. From this video onwards, we are going to launch our new course that is on Truffle. And with the help of Truffle, we are going to see how we can create our smart contract, compile our smart contract, and deploy our smart contract on a blockchain. And not only that, I'm also going to share with you my template that you can use to create your decentralized application with the help of Truffle and React.js code whenever you want. So this template will be like a boilerplate for you, which you can use whenever you want, wherever you want, in order to create your decentralized application from scratch. So be in this video and I'm going to share this template with you as well. So let us see the overview of this course, what we are going to learn in this course. So in this course, we are going to talk about Truffle. We are going to talk about why Truffle, because we have Remix ID already, right? So why we are going to use Truffle? We are going to see that. We are going to see the Truffle operations, that is compilation, migration, and other operations that Truffle actually provide us with. We are also going to see how we can use Ganache as a blockchain in order to deploy our smart contract on the Ganache blockchain. We are also going to see how we can create our smart contract and deploy it on a real Ethereum blockchain. And we are also going to see how we can create our decentralized application using Truffle and React.js code. So it will be a great course. And as I said, I am also going to share with you my template, which you can use whenever you want to create your own decentralized application. So talking about the prerequisite of this course, you should have a little bit knowledge of blockchain. Means if you know fundamentals of blockchain, what is Ethereum, then that's great. And if you have a little bit understanding of Solidity as a programming language, because we are going to take a small smart contract, like it will not be a big complex smart contract, it will be a small smart contract, like where we are going to set and get the value. If you know all these things, you are good to go and you can take this course. And during the end of this course, we are going to use a little bit amount of React.js, but that won't be a problem because 90% of the course will revolve around blockchain and Solidity only. 10% of the content, when we are going to create our decentralized application from scratch, a little bit knowledge of React.js will be good. So let's start with this course. And do let me know in the comment section, are you excited for this course or not? Hi everyone. Now in this video, we are going to talk about Truffle. Let us see the definition of Truffle so that we can understand Truffle in a much more better way. So what is Truffle? Truffle is a tool that helps you to easily develop, compile, test, and deploy your smart contract in your development environment. Now, one important thing that I want to point out here is that Truffle is a tool. Remember this thing, because what actually happens is that when we move towards, like when we progress in our blockchain, journey, what actually happens is that people get confused. Like, what is Truffle? What is Ganache? There are so many different terminologies in blockchain world. So I want to make sure that you understand this, that Truffle is just a tool. This is the tool which actually makes our life, or I will say makes a blockchain developer life very easy. So with the help of Truffle, you can create your smart contract, means you can create, develop, compile, test, and deploy your smart contract. But at the end of the day, it is just a tool. Okay, so remember this point. Now, if you will see these functionalities, all these functionalities can also be done with the help of our Remix ID as well, right? So you must be thinking like, why to use Truffle? Like I can develop my smart contract using Remix ID. I can compile my smart contract using Remix ID. I'm not sure about test, but I can deploy my smart contract using Remix ID. So what is the importance of Truffle? Why do we need to use Truffle, right? So this might be a question in your mind. And basically there are two reasons for it. First reason is that it actually provides you easy front-end integration. So let's say you want to create your own decentralized application. What is a decentralized application? Decentralized application simply means when you have your smart contract and you integrate this smart contract with your front-end, means with your React.js code or Next.js code. So when you integrate these two different technologies, what you get is a decentralized application. And in order to create this decentralized application, you need a tool. And that tool is Truffle, because it actually provides you easy front-end integration, which is not available in Remix ID. So if you will look in Remix ID, you do not have this kind of functionality, right? But Truffle provides you with this functionality where you can easily create your decentralized application, where you can easily integrate your smart contract with your React.js code or Next.js code, whatever code you are written, right? In like whatever technology you have used in order to create your front end. So this is the first use of Truffle. Second use of Truffle is that everything is actually, everything is in same place. Means by using Truffle, Truffle gives you this flexibility that you can create your code. You can write your Solidity code inside your Visual Studio Code. So with the help of which you have all your code at the same place. So let's say if you are creating your decentralized application, your React.js code, as well as your Salty code, both the codes will be at the same place, with the help of which you can easily create your decentralized application. So this is another thing that Truffle provide you as a blockchain developer, making your life as a blockchain developer very easy. And this type of functionality is also not available in Remix ID. And definitely there are other uses of Truffle as well, which we will see once we will start with our Truffle. Okay. But for now, these two I think are more than enough to understand that why do we need Truffle, because again, it is making the life of a blockchain developer very easy. Now enough theory, right? Let us quickly install Truffle and start using it. But before installation of Truffle, there are some prerequisites, like you need to have Node.js into your system, you need to have Git in your system, and you need to have Visual Studio Code in your system, because I'm going to use Visual Studio Code. Definitely you can use any other code editor, but I do not think like there is a better code editor as compared to Visual Studio Code. So I'm going to use this only. So, and the installation process of all these technologies are very easy. You have to simply go to their website and you can install them according to your need of your system. Okay, according to the need of your system. And you can go to YouTube or any other channel also, where you can find how to download these different technologies. Okay, so now let us go to our VS Code and then deploy, or not deploy actually, let us install Truffle. Hi, now in this video we are going to install Truffle. I hope you have already installed VS Code as well as Node.js and Git, so that you can install Truffle with me. And you can see this is this is my VS Code environment, and I have created this folder by the name of eTruffle course. Definitely you can name your folder anything you want. And now what we will do is we will quickly open our terminal. Now in order to open your terminal, you have to simply do Control plus backticks. Okay, and if you do not know about this, just simply go to file, like this particular option, then go to view. Inside view, you can also click on this terminal button, so it will open your terminal. So like this, okay, or otherwise you can use Control plus backticks as a shortcut. So this is my terminal. Now inside this terminal, I'm going to install my Truffle. Now to install Truffle, in order to install Truffle, you have to do npm, and let me zoom in a little bit, okay, so that everything is very clear. So npm, then I will do install, and then I will do -g and then Truffle. So by this, what I am trying to do here is I am trying to globally install my Truffle. If you will remove the -g option, then your Truffle will get installed only locally to this particular directory. But I am trying to install Truffle in a global space so that I can use Truffle wherever I want. Okay. I already have my Truffle, so I am not going to install it. Okay. And the installation process is again very easy. You have to just simply press enter here and it will get installed into your system. Now to check whether your Truffle is installed or not, you have to simply do Truffle like this and -- version. If your Truffle is installed, it will show something like this, as you will see on my screen. Okay. And if your Truffle is not installed, in that case, it will show you that Truffle is not a recognized command. Okay. So you have to do this, and then you have to check whether your Truffle is installed or not. Now, like sometime what you might face some problem while the installation, like for example, if you are doing npm install -g Truffle, now in this case, or I will say -g Truffle, so they're like you might face some problem, like how you can solve these problem. So first of all, what you can do is, if there is some issue during the installation part, what you can do is, if you're using Windows, you have to simply open your command prompt and run it as an administrator. And then what you can do is you can again install Truffle globally there. Okay. So you can do the same command, write the same command, and you can you can install Truffle globally there. And if you are using Linux, then you can use this sudo and then the installation process, because sometimes it creates problem for the installation of Truffle. Okay. So this is one of the solution. Or if you are facing any other kind of error, then do comment down below. I hope you will not face any other error, but do comment down below if you are facing any. Now let us see how we can use Truffle inside our Visual Studio Code. Now in order to use Truffle, you have to simply do Truffle, okay, once you have installed Truffle in it. So this is the command which will actually create all the folders that are required in order to create your smart contract, test your smart contract, deploy your smart contract. So as well as I will press enter here, so you will see that all our folders are created, right? Let us talk about all these folders. So this is our contracts folder where we are going to create our contracts, okay, like our salty code, okay. Then we have this migrations folder where we are going to write a migration script so that we can deploy our smart contract on a blockchain, okay, and you will see that. Then we have this test folder where we will write, like if we want to test our smart contract, where we can write testing script of our smart contract. Let's say if you want to test your smart contract, you can use Mocha as a framework child library so that you can test your smart contract. And then you have this Truffle configuration file, which is a very important file because you are going to configure your Truffle using this file only, and we will talk about this in much more detail. So don't worry about it for now. So this is the quick overview of all these folders. And let us understand all these folders by creating some files in it, right? Like if we talk about the earlier version of Truffle, like Truffle provides you example code, like for the contracts folder as well as for the migrations folder. But in the latest version, what I'm seeing is that they are not providing you any kind of sample code. You need to create your own sample code in order to compile, test, and do whatever you want. So first of all, let me create one file inside our contracts folder, because as I said, contracts folder will contain our smart contracts. And let me name my smart contract as simple storage.sol. Now inside my smart contract, I'm going to paste this simple code. Okay. So this is a very simple code, salty code. I hope you have taken my salty tutorial. So in this, if you will see, I'm simply creating a contract by the name of simple storage. I have these two variables, or I can remove one of these variables for now. So I have this one variable by the name of A, and I'm simply setting this variable A using this setter function and getting the value of this variable A by this getter function. And this is the salty code, right? .sol file, as you can see. Let me save it. And let us see how we can compile this smart contract. Like in Remix ID, we simply go to this compile button and we are able to compile all our smart contract, right? But let us see how we can do compilation of our smart contract using Truffle. So let me close this, and now we will simply do Truffle and do compile. Now once you will do Truffle compile, your salty code will get compiled. Means whatever salty smart contracts you will have inside your contracts folder, they will get compiled. Let me do this. Let me do Truffle compile, and you can see that as soon as I have clicked on this, this Truffle compile, our Truffle compilation process has begun. So compilation, then artifacts. We will talk about what is this artifacts. Then compiled successfully using Solc 0.8.17. So this is the Solc compiler Truffle is using in order to compile our smart contract. Now you will see that as soon as I have compiled this smart contract, a build folder is created, like on the left side, right? This build folder. Earlier there was no build folder, but now you can see that there is a build folder. And inside this build folder, you will see a JSON file, simple storage.json, which is just given, which is the name of your smart contract only. And let me open this simple storage.json. So if you have taken my salty tutorial, I have told you there, right? Whenever you compile your smart contract compiled code gets split into two parts. First one is ABI and second one is bytecode. And this simple storage.json is nothing but this is the combination of your ABI. If you will see, this is the ABI of your smart contract. I'm not going to talk about in depth about this ABI because I have already talked about this in my salty course. So I'm not going to talk about that. So this is your ABI and this is your bytecode, right? So this simple storage.json is actually consisting of your ABI as well as the bytecode of your smart contract after the compilation process. And this file is also known as artifacts in the Truffle terminology. So artifacts written to this particular, as you can see, build. Inside build, we have this contracts, and inside this, we have this artifacts. So you can also say that this simple storage.json is an artifact, okay, in Truffle terminology. But in simple language, this simple storage.json is nothing but this is your ABI as well as the bytecode of your smart contract. Okay, so this is how you can compile your smart contract in Truffle. Now you must be thinking like how this is different from Remix ID. Like in Remix ID also we can do the same. So why we are using Truffle here? So let me give you an example. Like let me give you a difference, like how compilation in Truffle and compilation in Remix ID are different. So let me create one more file here. Okay, let me create one more file here by the name of abc.sol, just a demo file, and let me copy the same code here. Or let me do one thing. Let me just copy this part and paste it and contract ABC, and just like this only. Okay, so we have this empty contract, and now let us compile this code again. Let me compile this code. So Truffle compile. So you will see that as soon as I am compiling this code, the compilation of abc.sol is taking place, and then compilation of simple storage.sol is taking place. So one important thing here is to note out that truffle compile command is actually compiling all the contracts given in our contracts folder. While if you will see in case of Remix, if there are, let's say, 100 smart contracts, you need to compile each of these smart contract manually, going to each of these smart contracts and then clicking on that compile button. While in case of Truffle, if let's say you are creating a big salty project where there are, let's say, tens of salty files or hundreds of salty files, and you want to compile your smart contracts, you can simply type this command truffle compile, and it will compile all your smart contracts that are present inside this contracts folder. So this is how Truffle is actually, winning over Solidity, because it is providing you this power to compile your smart contracts, all your smart contract at once, right? You do not have to go manually on each of them. You can compile all of those smart contracts at once. And now let us talk about the migration part. Hi. Now in this video, we are going to see how we can deploy our smart contract on a blockchain. So to deploy our smart contract on a blockchain, what we need is a migration script. So as I told you that in your contracts folder, you have your contracts. In your migrations folder, you have your migration scripts. So currently, you can see that there are no migration script. So we need to create one migration script in order to deploy our smart contract. So let me create a migration script. Now, whenever you are creating your migration script, so your migration script should be according to your contract name. So let's say I want to create a migration script for this simple storage.sol. What I will do is I will write this number 1. Okay, I will tell you the significance of it. Then underscore, okay, and then simple storage.js, so that you can easily find out that, okay, this migration script is for your simple storage.sol smart contract. In the same way, you want to create your, let's say you want to create your migration script for this abc.sol. Then what you will do is, again, you will do new file. In this, you will write 2 underscore and this, and then you will have abc.js like this. Okay, so now our contracts folder is ready, and now our migrations folder is also ready. So let me go to this simple storage.js, and inside this .js file, I will paste this code. Okay, so I already have this code, so do not think that it is through some magic or something. I have already copied this code, and now let me explain you this particular script. It's a very simple script in JavaScript. Okay, so if you will see, first of all, what we are trying to do is we are actually requiring the artifacts of our this particular .sol file, because as I told you, right, artifacts contain the ABI and bytecode, and that is what is needed when you are going to deploy your smart contract, especially the bytecode. So that's why we are actually having this bytecode actually, or the artifacts. And then we are actually using this script in order to deploy our smart contract on a given blockchain. Okay. In the same way, let's say if you want to create it for this abc.js, okay, so you have to simply again paste this code, and I will provide you the GitHub link of this code. So don't this particular script. So don't worry about it. Just make some changes. Like first change will be, instead of having simple storage.sol, what you will have is abc.sol here. So make it abc, and okay, I think the name is abc, right? And instead of this variable, you can change this variable. Definitely it is not necessary, because you can have this variable and you can use this variable for the deployment. But let's say for the sake of making it much more readable in nature, so abc, and then I will simply take abc and deploy it. Okay, so this is how you do it. So you do not need to remember it, or you not need to learn it. Simply copy paste this script and then just make some changes in this artifacts part. Okay, like whatever contract you want to deploy. Now another thing, if you will see that when I was creating this migration script, I was using this 1 and 2 number, right? So what actually happens is that whenever you are creating a big salty project, let's say you are creating a salty project which contains around 100 smart contracts, and or let's say 2 smart contracts only for the sake of example. Let's say there are 2 smart contracts, A and B, and your B smart contract is actually dependent on A smart contract. So in this case, what you will want is that first of all, your A smart contract get deployed, and then your B smart contract get deployed, because your B is dependent on A, right? So if B will get deployed first and A is not deployed, then it will give you an error, right? Because B is dependent on A, and when B will get deployed, it will search for A and there will be no A. So this numbering actually gives you a flexibility, like in which order you want to deploy your smart contract. So in this case, since I'm using one underscore for this simple storage, and in this simple storage, I'm using this simple storage.sol. So this smart contract will get deployed first, and then this smart contract will get deployed because this is on second number. But definitely you can change this number according to your need. So let me show you that as well. But before showing you that, let me go to our Truffle configuration file. So as I told you, right, that Truffle configuration file is the most important file which you are going to use a lot. Since we want to deploy our smart contract, so first of all, we need to tell Truffle configuration file on which blockchain we want to deploy our smart contract. Now let's say I want to deploy this smart contract on our Ganache blockchain. I will tell you what is this Ganache, so don't worry about it. But let's say I want to deploy this on our Ganache blockchain. So what I have to do is I have to make some changes to my Truffle configuration. So I have to just scroll down, and in this part, I have to make some changes. But before that, let us understand what is Ganache. Now in this video, let us understand what is Ganache. Ganache is actually a local blockchain simulator. Means it is a blockchain that you are running on your system. So whenever we create any smart contract, our final goal is to deploy this smart contract on a blockchain, right? And Ganache is Ganache is the best software for it because it actually provides you a blockchain simulator where you can quickly deploy your smart contract and test your smart contract. Because if you're thinking that I'm going to directly deploy my smart contract on a main network, then it can be a dangerous situation, right? Means if you're thinking I'm going to directly deploy my smart contract on a blockchain, first of all, it will cost you a lot of money, right? Because on a real blockchain, you have to provide some amount of money in order to buy cryptocurrency and other stuff. Second thing is it is dangerous, right? Because you haven't tested your smart contract. And Ganache as an environment provides you these two advantages. First of all, it is totally free of cost. Second thing is you can test your smart contract before deploying it on a main network on a real blockchain. Okay. So let us quickly install this Ganache and then we will deploy our smart contract on Ganache blockchain. Now the installation process of Ganache is very easy. You have to simply come to this website trufflesuite.com/Ganache, and here you can simply download Ganache. Now once you will download Ganache, you have to simply click on install and Ganache will get downloaded into your system. It's a very easy process, guys. There is no complexity into it. Just download Ganache according to your system. If you are using Linux, then you should install according to Linux, MacBook according to MacBook. Since I'm using Windows, I have to simply click on this download Windows, but I already have Ganache in my system, so I'm not going to reinstall it. But you can do it. You have to simply click on this download button and your package will get downloaded. Then you have to simply install it and just next, and it will install into your system. Now, once you will install Ganache into your system, you will get this kind of UI. Okay, so once you will open your Ganache, you will get this kind of UI. And definitely you might not see all these different things as you are seeing on my workspace because I have created them manually. In your case, it might be empty. But you have to click on this quick start button. So once you will click on this quick start button, you will get the Ganache UI. Okay, isn't it beautiful, right? And this is an area. This is your wallet area actually. What do I mean by wallet area? Because if you will see, you will have all your accounts, right? All your accounts, and all these accounts will have 100 ether as a balance, and all these are fake ethers. So do not think that you are going to sell them into the market and get some money. All these are fake ethers. All these are dummy accounts. So they are not real ethers or real accounts. Okay, these are just provided to you so that you can quickly test your smart contract, quickly deploy your smart contract. Okay, second area is your blocks area. And inside this blocks area, you are going to deploy your smart contract. So this will be an area where your smart contract will get deployed and a block will be created, which we will see. So don't worry about it. So you can see that already Ganache has actually provided with us with a default block. Okay, so this is a Genesis block, right? Because this is the first block of our blockchain. And then we have this transaction area, contracts area, events area. There are so many different, tabs given by Ganache, but for the purpose of this particular course, we are going to use only this accounts as well as this blocks tab. Okay, so now let us quickly go to our Truffle and deploy some smart contract on Ganache. So now, since you have understood what is Ganache, it is the time to deploy our smart contract on Ganache blockchain. So to deploy on Ganache, as I said, we need to make some changes to this part. So let me comment this out. Okay, and it is on line number 67 for me, but it may be a little bit, plus minus in your system, but it is on line 67 in my system, this development one. Okay, and in this, just make one change. Instead of port 8545, just make it 7545. Now, why I'm doing this, let me show you the Ganache. So this is your Ganache, right? And if you will see in this RPC URL, this RPC URL is actually used in order to connect to your blockchain. So if you will see, the host of this Ganache as well as for this RPC URL is same, right? 127.0.0.1. So this is same. The only difference is this port number, right? So this port number, we need to make some changes to this port number, and that's why instead of having 8545, I have made it 7545 so that I can connect it to my Ganache. If you are going to use 8545, it is the port number for your Ganache CLI. So you can also run Ganache in your CLI version, okay, inside this command line, but we are not going to do that because Ganache looks wonderful in UI version. So I'm going to use the UI version for now. Okay. So now once we have made these changes, we have to simply save it. Okay, this is it. Once you will make these changes, now your Truffle configuration file is ready. Now when you are going to deploy your smart contract, it will get deployed on your Ganache blockchain. So in order to deploy our smart contract, I need to simply write one command, truffle migrate, and then dash reset. Just do this. And once you will write this command, and if everything is correct in your migration script, then your smart contract will get deployed on the Ganache blockchain. So let's wait for our transaction to get confirmed, means to get deployed on the blockchain. So you can clearly see that the deployment process has started. And here you can see that. So first of all, as I said, this particular contract will get deployed, simple storage, because this is having number 1. And here are the details related to your smart contract, like on which block number it is deployed. And I have talked about all these things in the blockchain course, so I'm not going to talk about in much more detail here. So you can see that it is deployed on block number 1. This is the timestamp. This is the account which has actually deployed this smart contract. And again, this is for the ABC smart contract. This is deployed on block number 2, account number this. So by default, what Truffle is doing is, by default, it is selecting the first account as a default account for deploying your smart contract. So if you're not going to provide like from which account you want to deploy your smart contract, by default, Truffle will select this particular account only, the first account. Okay, that's why if you will see, both of these transactions are done from this account, 08E and 08E. Okay, so this is the by default. Now let us see this on our Ganache as well. So let me go to blocks section. Now in this is our block number 1. Here, this is your contract address, right? This is for your simple storage.sol, and you can check it, you can cross check it. So let me let us remind this, remember this, right? A9F. So let us see the contract address given here. So if you will see the contract address, it is A9F. So it is like we have made sure that, okay, our current smart contract is deployed on the block number 1 or not. In the same way, if you will go to block number 2, again, you will see your contract deployed on block number 2. And this is your abc.sol smart contract. Okay. And with this, we have learned how we can deploy a smart contract on a given blockchain. In the next video, what we are going to see, how we can deploy this block, like this smart contract on a real blockchain, because Ganache is a blockchain simulator, right? But we are going to see how we can deploy it on a real blockchain, but that in the next video. Hi. Now in this video, we are going to see how we can deploy our smart contract on a blockchain. But for the deployment purpose, we are not going to use a real blockchain. What we are going to use is a fake blockchain. And what is this fake blockchain? I will tell you, so just don't worry about it. For now, let us see how we can deploy our smart contract on this blockchain. So let's say you have this system, you have your own system, and this is your Ethereum network. No, actually not your Ethereum network, but yeah, this is an Ethereum network, okay, where you can see that all these people are the part of this Ethereum network. All of them are having their blockchain, right? Exact copy of the blockchain. And you as a system thought, okay, why not to become a part of this Ethereum network so that I can do transaction on the Ethereum blockchain, so that I can, deploy my smart contract, talk to my smart contract on the Ethereum blockchain. But the problem here is that currently your system is not capable enough. Your system is, I will say, a common system. because your system belongs to a real world part, while your Ethereum network belongs to a blockchain world part. So now we have these two different worlds, right? So we need to make some interaction between these two different worlds. If you have seen Avengers, you might be seeing where I'm getting into, right? So we have these two different worlds, and we have to make some interaction with these two different worlds. So how we can do that? So there are basically two approaches. First approach is that we can install a software by the name of Git. Okay, so this is a client actually. So once you install this Git software into your system, you become a node. And once you become a node, you can be the part of this Ethereum network. You can do all the transactions, you can deploy your smart contract, and whatever you want to do, you can do on the Ethereum blockchain. So now, like, you are like an errand man, right? You can go to this blockchain world and you can talk to this blockchain world now. But the problem with this approach is that this Git, right? This Git, installation of this Git and using this Git is not a very easy process. First of all, it is not an easy process, and second of all, it requires a lot of system requirements. Like you need to have some around 512 GB of RAM, not actually 512 GB of RAM, sorry for that, 16 GB of RAM, 512 GB of SSD space. So there are so many prerequisites in order to use Git on your system. So this approach is not a very good approach if you are just a beginner and you are thinking to talk to this Ethereum blockchain. So we have this second approach, and the second approach is to use softwares like Alchemy and Infura. Okay, so what is this Alchemy or Infura? Let us see this. So again, you have this normal computer, right? And this normal computer want to talk to this Ethereum network. Now, in order to make this talk, in order to communicate with this Ethereum network, this computer need an endpoint. Okay, and we will talk about this endpoint, so just don't worry about it. And this endpoint can be either Infura. Now, this is the logo of Infura. Okay, so this is Infura. And this Infura actually act as a bridge between your normal computer and between this blockchain world application. So now you have this bridge, right? This is your wormhole talking with, you can now go to this wormhole and you can talk to different people, right? So in the same way, this Infura is actually your bridge, which is actually helping you to talk to this Ethereum network. So now this real world application, or I will say this real world computer, will be able to talk to this blockchain world application, or I will say technology. Okay, and there are alternative of Infura. You can also use Alchemy. Alchemy is also an alternative to Infura, which you can use in order to deploy your smart contract on the Ethereum network. And for the purpose of this video, I'm going to use Alchemy. Definitely you can, again, as I said, you can use Infura, but I'm going to use Alchemy because I think Alchemy is free. First of all, Infura is also free, but I think Alchemy is much more flexible than Infura. So I'm going to use Alchemy, but you can do the same for Infura as well. Okay, again, I'm telling you this. So let us quickly go and let us use Alchemy in order to talk to our Ethereum blockchain and quickly deploy our smart contract on the Ethereum blockchain. Now, since we are going to use Alchemy for the deployment of our smart contract over Goerli test network, first of all, we need to sign up to Alchemy. Okay, and if you are already signed up to Alchemy, you can directly do a sign in. Now, once you will do a sign in, you will see a dashboard. Okay, like this. Okay, now in this, what I will do is I will simply do one thing. I will show you by deleting one of my apps here, because there are so many different apps I already have created. So I need to delete some of these. Let's say I want to delete this one. Okay, well, delete this. I'm just deleting it because I do not have any space to create one more app. Okay, to use one more Alchemy ID. So that's why I'm doing this. In your case, you do not need to do this. Now, once I have deleted it, now I can create a new app. Now, in order to create a new app, I have to simply click on this create app button. Once I will click on this create app button, I need to give a name to my project. So let's say this is Truffle. Okay, Truffle E project. Okay, so you can name it anything, whatever you want. Now, under change section, I will be choosing Ethereum. Definitely there are so many different options, but since we are going to use Ethereum as a blockchain, that's why Ethereum. And for network tab, I'm going to use a testnet, that is Goerli, because if I'm going to use main network, you can use a main network here, but it will be a costly affair. You need to buy some ethers so that you can deploy your smart contract. But the process that we are going to see using Goerli test network, this is the same process that you are going to follow for the main network deployment as well. So let me select Goerli for now, and now I will create this app. So now my endpoint is created. Let me see this. So where it is, Truffle E, view details, or not view details, actually view key. So these are the API key that I'm going to use in order to connect to Alchemy, and using Alchemy, I'm going to deploy my smart contract on Goerli test network. So let us do this quickly. Now, since we want to deploy our smart contract on Goerli test network, we need to again make some changes in our Truffle configuration file. Okay. So what I'm going to do is, first of all, I will comment this line again out because I'm not going to deploy it on Ganache. And in order to deploy on Goerli test network, I need to comment out this particular line where you can see Goerli, provider, network ID, and all these different details. Now, in order to deploy it on the Goerli test network, I need to have these two things. First of all, the mnemonics, okay, which we will get from our MetaMask. And I have talked about all mnemonics and everything, like about the MetaMask wallet in my Solidity tutorial. So I assume that you know about mnemonics, okay? But I will tell you a little bit brief about mnemonics so that you are not confused. And then another thing that we are going to need is this API key. Like currently, if you will see, by default, it is showing the API key for Infura, but I'm going to use for Alchemy, right? I'm going to use Alchemy, but definitely you can choose Infura as well. It's your choice. So first of all, let me go above and let me zoom out a little bit, right? Okay. Now in this, I will first of all comment out these two lines. And if you will see here, we have this package by the name of .env. Now what we are going to do is we are going to store our mnemonics, which is actually our private key, as well as our project ID. And project ID is this thing, right? This is your project ID. So we need to keep these two things secret. Okay, you cannot share these two things with anyone else, because if you are going to share these things with anyone else, then you will have to pay for them, right? So like if someone has your mnemonics, they can take out all your cryptocurrency from your wallet, which I don't think so you want. And another thing, if you are going to use project ID, then this project ID is actually provided by Alchemy. And let's say if you are deploying this on a real main network and somebody has your project ID, then they can use Alchemy. Then they can use your Alchemy in order to connect their smart contract. And this will actually cost you some money again, because using Alchemy is actually, if you are using Alchemy, you have to pay some fees. Now, in this case, we are not going to pay any fees because we are not going to do anything on the main network tab. But if you are thinking that I'm going to use Alchemy for my for my large project or for some decentralized application which I'm going to deploy it on main network, in that case you need to pay some amount of pricing for Alchemy, which you can check in this pricing tab. I think in this, I'm not sure where it is, but you can check it on Alchemy website. So you need to have these two things very secure so that nobody can see these two things. So for that, what I'm going to do is I'm going to create one more file by the name of .env. Now this .env file is a file which is actually which you keep secret, which you do not share on your GitHub profile. Okay, so this is something which you keep under your .gitignore file so that nobody can have access of your .env file. Now inside this .env file, I'm going to have this mnemonic. Okay, mnemonic, and then I will have my project ID. So let me have my project ID. Okay, now let us see our project ID, which is given on Alchemy. So this is our project ID, right? Project ID actually. Let me go back. Let me paste my project ID here. Now for mnemonics, I need to go to my MetaMask wallet. And why do we need mnemonics in this case? We need mnemonics in this case because we are actually going to deploy our smart contract over a test network. And occupying some space on blockchain will cost you some amount of money. So for that, we need a wallet which will actually do this kind of transaction, because when you are actually occupying some space on blockchain, you need to pay. And who will pay this? You will pay this. So for that, we need mnemonics so that when we are deploying our smart contract, this is done from our wallet only and some amount is detected from our wallet. Okay, so that's why. We need mnemonics, and mnemonics are basically required whenever you are doing any write operation. If you are reading from a blockchain, then it does not cost you any money, but if you are writing on a blockchain, then it costs you money. And since you are deploying your smart contract, it is like changing the state of the blockchain. You require mnemonics. And I have talked about mnemonics, MetaMask, and Goerli test network in the Solidity tutorial. So again, I will suggest you to watch those if you haven't watched those. And for mnemonics, what I will do is I will simply click on this button and I will go to settings. In this, I will go for privacy, reveal secret recovery phrase. and then I will simply type my password. And again, do not share this mnemonics with anyone. I'm just showing you how to do all these things. I'm just demonstrating you. That's why I'm able to share this. Like, that's why I'm sharing this, because I do not have any cryptocurrency in my wallet. But for you, you should never share your mnemonics, this thing, with anyone. Okay. So let me copy this down. Okay. So it is showing that do not share this phrase with anyone. And then we will paste these mnemonics here. Okay. And then, since in order to use this .env file, we need this .env package, we need to install this package. So let me do npm install .env. So this will install this .env package. Now, once it will be installed, we will be able to access our mnemonics as well as our project ID. And another thing that we are going to require is this HD wallet provider. Okay, so this will be acting as your wallet, which you can see here as well, that when you are actually providing your provider, you are actually creating this object, right? And inside this object, you have this mnemonics and this API, right? So we need to install this SD wallet provider as well, this package, so that we can use this package. And for that, I'm simply going to copy this particular line. Okay, this line. And then I'm going to do npm install. And if you're seeing any kind of error, then I will suggest you to again go to your command prompt, run it as administrator, and then install this package. Okay, so that you do not have any kind of error. So, okay, so now it is installed as well. Now, the only change we need to make is this particular URL, right? This URL is of Infura and we are using Alchemy. So what I will do is I will simply copy this part of the URL. Let me copy this. So what I will do is let me paste it for now here so that I can. So I do not require this part because this part is already present in my project ID. I will simply copy this particular part. Okay. And this is same for all of us. So you do not need to worry about it and just simply paste it here. Okay. And just remove this from here. Okay, I just okay, now let me remove this from here. Okay, so now we are ready for the deployment. I know it is a little bit complicated process at first, but it is a very easy process. Like for deployment on a test network or on a main network, you need mnemonics, which you will get from your MetaMask wallet, and then you need this API, which you will get from Alchemy, and then you need this SD wallet provider so that you can work on it, right? And just simply save it. So now we have everything ready. Now what we are going to do is we are simply going to deploy this. So first of all, let me clear my console. I will do truffle. So this is the command in order to deploy this on our test network. -- network, and then we will have this Goerli, right? This Goerli. Okay, so Goerli and -- reset. Let me press enter. And if everything is correct, this smart contract will get deployed on the Goerli test network and we will check it on Goerli test network as well. Now the migration on test network will take some time because migration on test network, like test network behaves just like your main network. So it will take some time to get deployed, around 15 to 30 seconds. So we need to wait for some time. Okay. So in my case, if you will see, it has thrown an error that it is not able to deploy it on the Goerli test network. Now, sometimes actually there are some issues with this HTTPS protocol. So what we need to do is we need to use another thing, that is WSS. Okay. And one thing I will also do is that I can delete this abc.solve for now because we do not require it for now. Otherwise, it will just take more time to deploy both of our smart contracts. So let me delete it for now. And if you are getting the same error, if your smart contract is deployed, then that is wonderful. Okay, but if you are getting some kind of error, in that case, what you need to do is you need to again go back. You need to copy this WebSockets URL. Okay, and then you need to paste this here. So what I will do is I will come here and then okay, I will simply paste it. Again, I will take this particular URL part. Okay, and just paste it here. So this part is the project ID, which is the same. So we do not need to worry about it. Just save it. Let us try to deploy this once again. So I will simply do again upper arrow key, and then I will simply again deploy it. Now let's see whether it is now deploying on the Goerli test network or not. So wonderful. If you will see now, it is deployed on the Goerli test network. As I said, right, sometimes HTTPS does not work. In my case, it never works most of the time. Earlier it worked, but I do not know why it does not work now. But if you will see now, since I have used WSS, right, this WebSocket one, now it is working perfectly correct. So if you will see here, you will see your smart contract, simple storage, which is deployed on this particular block number that is around, I think, 830,000 something. I'm not sure. It's a big number. And then we have this contract address where it is deployed. What we can do is we can simply copy this address. Okay. And let us see which account is used for the deployment. If you will see, this account is used for the deployment, right? Let us see this account first of all, and then we will see the this particular contract where it is deployed on the blockchain. So hooray, it is deployed. One thing is for sure. So if you will see, this account is actually used, right? This MetaMask account is used for the deployment of our smart contract, because as I said, when you are deploying, you need to sign your transaction stating that this is my transaction, this is my smart contract. So deduct some ether from my account. Okay. And now let us go to Goerli Ether scan. Okay. Where we can check whether our smart contract is deployed on the Goerli test network or not. So I will paste the contract address. I will search on it. And here it is. You can also search for this contract address and just click on the transaction hash, and wonderful. So now we have our smart contract deployed on the Goerli test network. This is the contract address. This is the account used for the deployment. This is the block number, and we have just deployed it right 2 minutes ago. So this is cool, right? This is cool. I like this thing. Whenever I do this, I just feel like, wow, this is something amazing, right? Talking to the blockchain, deploying your smart contract. It's cool. I must say, this is cool, right? So this is how, guys, you deploy your smart contract on the Goerli test network. In the next video, we are going to talk about the difference between Ganache and a test network. So let's see this. Now let us see what are the differences between Ganache and testnet. Because if you will look both of them are actually doing the same thing, right? Both of them are actually providing you with environment where you can test your smart contract. So you can test your smart contract in Ganache as well as on testnet, and that too free of cost, right? But there are some significant differences between Ganache and testnet. Let us see this. So first of all is that Ganache is more like a centralized system. Like when I'm saying centralized, what I'm trying to say is that your Ganache is just on your system, so it is working according to your system only. While if we talk about testnet behaves just like your mainnet. So there are no differences, or there are certain differences if then 95% of the time your testnet is actually behaving just like your main network. So this is something where testnet actually wins over Ganache, right? Because testnet is providing you with the same environment just like your main network. So this is very important to know. Second thing about Ganache is that migration time, or I will say any operation that you are doing on Ganache, is very less, right? Because Ganache is just working on your system. While if we talk about test network, migration time is just like your main network. So it is taking around 15 to 30 seconds or more than 30 seconds for your transaction to get processed, right? Just like your main network, Ethereum main network. Third important thing to know about Ganache is that it is not reliable for the final testing of your decentralized application. So if you want to quickly test your smart contract, okay, whether my smart contract is working fine or not, in that case, Ganache is a good option. But if you're thinking that after checking my smart contract on Ganache, I'm going to deploy it directly on the main network, then this is not a good thing to do, because your Ganache is very centralized, right? It is very, it is just a simulation, blockchain simulation, which is not actually working like your main network. While if you are finally, like if you want to do a reliable final testing of your smart contract, whether your smart contract is working correct or not, then you should first deploy it on a test network, check it there, and then only go to the main network. So if I will say the in which order you should test your smart contract, first of all, you can use Ganache just to quickly check all the operations, okay, because Ganache is easy, because you do not want to wait for every transaction to get processed, right? 30 seconds, which is very irritating. So first of all, you can do quick testing using Ganache, then you can do a testing with your test network, and then you should go to the main network for the final deployment. Okay, so these are some differences between your Ganache and the test network. So now is the time to deploy our decentralized application using Truffle, right? So we have seen how to deploy a smart contract using Truffle. And now we are going to see how we can create a decentralized application using Truffle as well as React.js code. Let's start, and this is, I think, the most exciting lecture because we are going to create our own decentralized application from scratch, as well as I'm going to share with you one template that you can use whenever you want to create your own decentralized application, so that you do not have to go for the same hustle again and again. You can simply copy paste that code and you can start your decentralized application. So let's start. So in order to create our decentralized application, we need to create, first of all, truffle folders, because these truffle folders will consist of our smart contract, and with the help of truffle we will deploy our smart contract on our blockchain. Okay, so first step will be to have truffle. Then the next step will be to have our React.js code, so that we can create the front end of our decentralized application and then connect our smart contract with our React.js. So I will do npm install create React app, okay, like this. So this will actually install our create React app. Okay, so now it is installed. Now I have to do another thing. I need to have npx create React app and then the name of my folder. So I generally prefer client as the folder name, but you can have any other folder name, whatever you want. So, but for my case, I'm going to have a client folder. Now inside this client folder, we will have our React.js code, and then we will create our React.js, like we will create our front end, and then we will create connect our front end with our smart contract. Now, in order to connect our front end with our smart contract, we need to have a smart contract, right? So let us have our smart contract. Now in this contracts folder, I'm going to create again the same smart contract that we have used till now, that is simple story.sol. So I will paste this code. So I hope you have this code, or if not, then you can take it from the GitHub profile, which I will share below, GitHub link actually. So this will be our contract, and we are going to use this contract to create our decentralized application. Then again, we need to have our migration script. So I have provided you with the script, right? So you can simply use it now. So one simple storage. So till the time we are doing all these things, our React application will get installed. Okay, so here we have this code, right? Simple story.sol. Okay, and we can delete this test folder because we are not going to do a testing of our smart contract. And then inside our truffle configuration, so we will deploy our smart contract and Ganache blockchain, but definitely you can deploy this smart contract using Alchemy on a test network, and then you can create your decentralized application as well. But in our case, I'm going to do it on Ganache blockchain, but definitely it will be your assignment that you need to create this decentralized application on a Goerli test network. Okay, but first of all, let me do it for Ganache blockchain. In order to create it for Ganache blockchain, again I need to go to the development part and uncomment this part out, and then inside it I will have my 7545, right? So the same steps. The only thing that I'm going to have extra inside it will be this particular code, and I will be sharing the truffle configuration file with you as well, so you can directly copy paste it. So this particular code will actually make sure that when we will compile our smart contract, the artifacts, right, the ABI and the bytecode of our smart contract get created inside this client folder. And I will show you that, but for now I'm just copy pasting this particular thing here. Okay, so this will be the only change that I am doing in my truffle configuration. Other thing is the same, that I am using Ganache as a blockchain in order to deploy this smart contract. Now once this is done, and you can also see that our our React.js code is also ready. So let us check this as well, so that we are sure that it is working fine. So let me see the client and let me do npm start. So let's see whether our React application is working in a correct way or not. Let me remove this for now. Okay, let me close this. So if everything will be working fine, you will be seeing a logo of React.js. Okay, so wonderful, right? So we have this React.js logo. So our React application is working absolutely correct. Now, what we will do is we will, in order to interact with our smart contract, right? In order to interact our React.js code, like if we want to have an interaction between our React.js code with our smart contract, we need to have ABI of our smart contract, right? And I have told you all this in my Solidity tutorial, where I've told you, right, that whenever you want to make any interaction with your Solidity smart contract, you need ABI of your smart contract. So the first step will be to have ABI of our smart contract. And how can we have our ABI of our smart contract? By simply compiling our smart contract, right? So I will split this particular terminal, if you will see. And what I will do is I will directly do truffle migrate reset, because when we migrate our smart contract, in that case compilation automatically takes place. And when this compilation will take place, let me show you this truffle configuration file again. So you will see that our contracts folder, like this contracts folder, will contain the ABI and the bytecode will be generated inside this SRC folder. So inside your client folder, you have to go to this SRC folder, and then you have to, like when you will go inside it, you will see that there is no folder currently, right? But after this compilation, you will see a contract folder will get created, which will have the ABI and bytecode of our smart contract. So let us see that. So you can see that as soon as the compilation is done, you will see that you have your contracts folder, and inside your contracts folder, you have your ABI and bytecode. Okay. So you can copy paste it, like if like what you can do, like other option was that instead of having this particular line in your truffle configuration, you can directly compile it and you can just copy paste the bytecode in this particular folder. But I think we are developers, right? We need to do something good, right? So that's why I pasted that particular code, right? That build code, so that it get generated inside our source folder, inside our contracts folder. It this actually .json file get generated. So now once we have this JSON file, now what we can do is we can make an interaction with our smart contract. As you can see, our smart contract is also deployed, right? Let me show you. You can see that our smart contract is also deployed. And if I will go to my Ganache side blocks, so on block number 1, we have this contract address that is 0 cross EC034D, right? Okay. So now the part 2, like now we have to make an interaction. Now in order to make this interaction, first of all, I have to go to this SRC folder. And if you are not familiar with React, just don't worry. I'm going to explain you each and everything, but not in much detail, and a little bit, on a surface level. So I have to go to this SRC folder, and inside this SRC folder, what I will do is I will simply go to my app.js, and if you will see, this app.js code is the code which we are actually seeing on our browser. So I will show you that edit src app.js code. So the same thing is actually visible here as well, right? So what I will do is I will simply remove all this code, because we are not going to have this. Instead of it, we will create our own decentralized application, and we will remove this particular code as well. Now, before starting with our decentralized application, let me show you the decentralized application that we are going to create. Okay, so that you have that end goal in your mind. And when we are going to create our decentralized application from scratch, you do not have any kind of confusion. Okay, so this is how our decentralized application will look like once we will complete it. So we will have this contract data, and this contract data is actually fetching the data from our smart contract. So if you remember from our smart contract, we have two functions. First one is setter function and second one is getter function. And in this particular case, we are actually calling this getter function, and we are fetching the value of our state variable a, right? We have this a state variable, we are fetching that particular value. And by having this input text, we are actually calling the setter function of our smart contract, and we are going to code each and everything from scratch. So don't worry about it. So now if let's say I want to change the data value of our smart contract from 20 to 30, I have to simply click on this change data, and now we have this 30. So we are going to create this simple decentralized application, because we are just going to see how we can create decentralized application using Truffle. Okay, so this is a very simple decentralized application, but with the help of this decentralized application, I guarantee you are going to learn a lot. So now let us go back to our Visual Studio Code, where we are going to create our decentralized application from scratch. So now it's the time to create our decentralized application. So the first step will be to create our template. Okay, so the first step is to create our template, so that you can copy paste that particular template and you can create whatever decentralized application you want to. Now in order to have this template, what I need to do is, first of all, I need to install one package. Okay, so let me clear this particular field. Okay, so I'm using this second terminal. And now I'm installing one more package by the name of Web3. This Web3 is actually a package with the help of which we are going to make an interaction with our smart contract. Okay. And definitely in future, I'm going to create a course on this web3.js library. Okay. But for now, since we are just using Truffle, so I'm not going into the depth of this Web3. I will just tell you how to use this web3.js library in order to interact with your smart contract. But in future, definitely I will create one course on web3.js, which you can check out. Okay. But for now, let us do it. So now once we have installed this web3 package, I need to import it. So I will do import, and then I will simply import this particular package. Okay. I will do web3. And then what we will do is we are going to have our use state and use effect React hooks. Okay. I will directly import it for now so that I can directly use them. And then what we will do is we will create one object using our use state. So that object will be state object, and then by using this set state function, we will set the state value. Okay. And initially, let's say this state value will have web3. Okay. So this will be the key and it will be null initially. And then we will have our contract, and then we will have null here. Okay. So this is the syntax of your React.js code. This is the syntax of your JavaScript code. I hope you know all these things. If you do not know, just don't worry. And what I'm trying to do here is that I'm simply using use state hook. Okay. I'm simply using this use state hook in order to set the value of this object. That is like this particular object, actually state object, in which web3 is the key and initially it is null, and contract is the key and initially it is also null. Okay. Now what we will do is we will create use effect hook, and in this use effect hook, what I will do is I will have my provider. And what is this provider? This provider is actually something which actually help us in connecting to our blockchain. So I will do const provider new web3. So I have imported this, right? So new web3 dot providers dot http provider. Okay. And inside this, I will have the RPC URL of my Ganache. So inside this, you will have that particular thing, like that particular blockchain which you want to connect with. So this is the provider. Okay. And then what we will do is we will create one function by the name of template. Definitely you can name it anything. I'm naming it template because it is just like a template which you can copy paste and you can create your decentralized application whenever you want. Okay. And inside this again, okay, this will be an async function because I'm going to use promises and everything. So yes, that's why. Again, we will have our f3, and this web3 will be equal to web3, and inside this we will have our provider. So this web3 is actually something which is actually help us in order to interact with our smart contract. So let me console it for you. And again, I will publish a course on this web3.js library. Then I will explain all these things in much more detail. So for now, I'm just telling you the most important things. Okay. But in the web3.js course, I will be explaining you each and everything. But for now, let me console.log this particular thing and let me call this function template. Okay. And we will call this particular function only when we will have our provider. So I will have this provider and template. So this will make sure if we have provider, then we are going to call this template function. If we do not have any provider, then we are not going to call this template function. And inside our dependency list, we will make it empty. Okay. So we will not have anything here. Let me save it so that I can show you this particular object. And one thing, just make sure one thing, that your Ganache is running when you are doing this thing. Because if your Ganache will not be running, in that case, it will throw you an error. So make sure when you are connecting with the Ganache blockchain here, right? So your Ganache must be running. Now let us go to our browser, and in this I will do Control plus Shift plus J so that we can open our console. And inside this, if you will see, we have our web3 object. Let me open it. So you can see that this web3 object consists of so many different methods. Okay. And we are going to use one of these methods in order to interact with our smart contract. And that method will be this particular eth part, this eth module we are going to use in order to interact with our smart contract. So this is done. Now, in order to interact with our smart contract, we require two things. So let me write it down here. To interact with our smart contract, with a smart contract, actually, we require two things. Okay. And the first thing is, as I told you before as well, ABI, and second thing will be the contract address, because without the contract address, I will never know, right, where my smart contract is actually lying. So I need to know the contract address as well as the ABI. Now for the ABI part, we are sorted because our ABI is actually present inside this SRC folder, inside this contracts folder, right? And now what we will do is we will simply import it. So I will do import simple storage, okay, from in the current directory only, right? In the current directory, because app.js and contracts folder are both in the same directory. So contracts slash and simple storage.json. So I will import this simple storage. So now we have our ABI, and the only thing that now we require is the contract address. So how we can get the contract address? So in order to get the contract address, I need to have this network ID, and you will understand all these things. So just don't worry about it. We will have await web3.eth.net.get ID. Okay. This network ID, which will actually help us in order to get the contract address. So that's why I'm having this. Let me create one more variable and I will show you the contract address as well. So deployed network. Now what I will do is I will use my simple storage, right? The artifacts or the ABI that I have imported. I will say the artifacts because we have imported everything, right? Now in this, I will go to the networks part and then the network ID part. Now with the help of this, what I can do is I can show you the contract address. If everything will be working fine, I can show you the contract address by doing deployed network dot address. So this will actually help us in getting the address of our smart contract, and we require the address of the smart contract, right? So let me show you that as well. So let me go back. Let me refresh it. So now if you will see, this is showing us the contract address. So this is a good news, because if we will go to our Ganache in the block section, in the mind section, so I think, okay, no, this is a different contract, right? I think I have done a lot of deployment previously, so that's why it is the thing. Let me see where our contract is lying. Okay, here is my contract. Where is my contract? Here it is. So this is my contract, right? If you will see. So this is the contract which is actually deployed on block number 1. So 0EC0, and this is the same contract that we have now deployed. Means we have console.log. We have already deployed. We are just fetching the contract address. Okay, so the only thing that we are doing is fetching the contract address. And how I'm able to fetch this contract address? Let me show you the simple storage.json file. Inside this, if you will go to the networks part, show you where it is. Let me search for it. Networks. So inside this networks part, you can see that this simple storage.json is actually consisting this address of our smart contract, and that's what we have done here as well. We are simply fetching the contract address. So now we have all the things ready, right? Now we have the ABI as well as the contract address. So now what we need to do is we need to create an instance of our smart contract with the help of which we can talk. So what I'm trying to say here is, what I will do is I will create one more instance of our smart contract. I will tell you what this instance is all about. In this, I will do new web3.eth. So if you will see, now here also I have used this web3 object, and now also I'm using the same web3 object in order to create the instance of our smart contract. So contract, and inside this I will pass two things. First one is the ABI of our smart contract, and second one the deployed network, means the address of our smart contract. So now we have the ABI, okay, and the deployed address, and this is what we need in order to interact with our smart contract. So now this will be the instance of our smart contract with the help of which we are going to interact with our smart contract. Let me show you this as well. Let me show you this. Let me console this so that you can see this as well. So now console.log. Let me again go to the browser. Here it is. Let me refresh it. So again, this is the instance of our smart contract, and you can see this, that this is having the address, right, of our blockchain where it is deployed, the contract address. And if you will see in the method section, in this method section, you can see this is your getter function and this is your setter function. Isn't it great, right? It looks so nice, right? And now we are going to make an interaction with this contract. So this is our getter function and this is our setter function, which we are going to call using this contract instance, right? So this is the instance of our smart contract. Let me write it down so that you can check it out afterwards. So instance of our contract, with whom we are going to make, an interaction. Okay, this is good, right? I'm excited. I'm actually very excited. Tell you the truth. Now, what I will do is in the last step, since now we have the contract instance as well as the Web3 object, so I will simply set the value, right? I will simply set the value. So set state, and I will set the state with web3, right? The new web3 that we have just created, and contract. Okay, so this is the syntax of React.js. Okay, I am assuming you know a little bit of React.js. Okay, so what we are trying to do here is we are simply setting this particular value. Okay, now this is great, right? This looks so great. Now we can see this value as well. Let me show you that as well. I'm trying to show you all these values so that you are confident enough that like what I'm trying to do here, you are not confused like, okay, what is going on here? I'm just trying to console.log each and everything so that you can see by your own eyes what I am saying is actually happening or not. So now let me do console.log the state. This is the object, right? See, let me refresh it, and here this is our contract, means this is our object which is actually containing the web3 object as well as the contract instance. So this is the web3 object. You can clearly see this has the eth method, right? Eth module actually, and this is the contract instance. Again, you can check because this is having the methods getter and setter, so we are sure that this is our smart contract only. So now this is done, the first part is done, and as I said, you can just copy paste down this template that I have just provided you, right? And you can use this template whenever you want to create an instance of your smart contract, and you can interact with this instance of your smart contract. And don't worry, I'm going to make an interaction as well, but I just want to show you how simple this process is. You can simply copy paste this and you can use it whenever, wherever you want. Okay. So now we have completed the template of our decentralized application, right? So our template is ready. Now it's time to read some data from our decentralized application. So let's make one function which will actually help us in reading the data of this smart contract. Means with the help of that function, I will be calling this getter function. So let us do that. And before doing that, let me do one change here. So by mistake, I have written contact here. It should be contract. Okay. And now what I will do is, let me comment this out. Now what I will do is I will create again one use effect, because I want that this function runs automatically as soon as our React application get rendered. And inside this, I will create a function by the name of read data. And this read data function will be reading data from our blockchain. And to read data from our blockchain, first of all, we will be needing the contract instance, which we will get from the state object that we have set it here, right? This contract by initialize contract by this particular value. So I will get that particular contract, right, by destructuring this object. So I'm using the destructuring thing of JavaScript. And then what I will do is I will simply create one more basically variable, and then I am going to use this contract instance. Okay, and then I'm going to use the methods dot getter function. Now what I'm trying to do here is, let me tell you. So in this, I have used this contract instance. Okay, first of all, and then this is the syntax to call a function of our smart contract. So first will be the contract instance, then you have this keyword by the name of methods, because you are actually calling one of the methods of your smart contract, and then you will have your contract function name. So if you will see, you have this getter function name as getter, right? Getter function name will be getter only. So I'm having this getter function, and then I am calling this getter function. Okay. And remember one more thing regarding this particular call function, that whenever you are reading something from your smart contract, then you are going to use this call function. And if you are writing to your smart contract, then you are going to use the send function, which we will see when we will write something on this blockchain, when we will call this setter function. But I will tell you about that in that particular video. But for now, let me console.log this particular data so that we can check, and then let's call this particular function read data function, and I will call this read data function only when I have my contract instance. Okay, so that it does not throw us an error, because if the contract object is not ready and if you are calling this read data function, in that case definitely this line will throw us an error, right, which we do not want. So what we are trying to do here is that if contract object is ready, then only call this read data function. And for the dependency I will have the state, okay, and then I will simply, okay, what I did, I think I made some mistake or something like that. Now let me save this particular thing and let me go back to the browser. So now I will do Control plus Shift plus J. Okay, so we have some error here. Okay, so I think, okay, my Ganache is not working, guys. So this is the mistake which actually happens when your Ganache is not running. So now in my case, my Ganache is not running. That's why I'm facing this issue. Let me open my Ganache. So this type of error occurs whenever your Ganache is not working, or wherever the blockchain that you are connecting with is not working. Let me, okay, nice. So now again I will refresh it, and okay, return value, okay, some issue. Let's go back. Let me try to save it once more. Let me go back here, refresh. Okay, it's saying that while it did not run out of gas, you model see this if you are not using okay, I think I made up again, because see, it's good that this mistake happened in this particular video, because when I actually restarted my Ganache, my contract address, like the contract that I have deployed in the on this Ganache blockchain, also got destroyed, right? Because now currently you will see that I do not have my contract. So what this error is actually saying is that the contract ABI, right, the contract bytecode that you are looking for is actually not there. So that's why it is showing this error, because our contract does not exist, right? If our contract does not exist, then how we are going to make an interaction with it? So remember this, that if you are, let's say by any chance you are going to restart your computer or restart your Ganache, in that case remember to redeploy your smart contract, otherwise you will face this error. So let me again redeploy this. So I will again deploy this smart contract, clear it. So truffle migrate dash dash reset. It's good that this particular mistake happened in this video. Otherwise, if you will get this type of mistake, you might get confused, right? So now again the compilation has taken place. Now our smart contract will get deployed on the blockchain, and now we will be able to interact with our smart. Let's wait for some time. Wonderful. So now let's go back to our browser. Let us refresh this. And now here you can see that it is showing us 0. Now why 0? Because in our smart contract, currently this A is by default 0, right? Because this is a UNT type data type. And for a UNT type data type, if it is not initialized, then by default value is 0. So this is great. We are going great. So this is nice. Now, instead of consoling.log like this value, right? We are consoling this value on our browser. Why not to show this value on the window part of our browser? Means at this particular area. Now, how we can do that? We can do that using the use state hook, right? So what I can do is I can go above, and here I can create one more use state, and it is by the name of data set data, and let us make this nil. And initially let me make this nil. Okay, so currently we have no data. And then once we will have the data, instead of consoling.log, what we will do is we will set this data, right? So that we have this data in our state and we can use this data, right? So in order to use this data in this particular React application, what I will simply do is I will do, and definitely I will use the CSS part afterwards, but for now let me just do it like this only. Contract data, and just some space, and inside this we will have the data value, right? This data value that we are setting here, right? This particular value, so that we can see this value on our browser as well. So now let us see this. So now you will see we have this contract data, which is initially 0. Now it's time to create one more function with the help of which we are going to change the value of our smart contract. And to make this function, I need to again create a function, right? To make this function, like I have to make this function actually. So the function name will be, let's say write data. Okay, which will be writing the data on our smart contract. So again, we will, instead of having any variable, what we can do is again we can have await, and we need to again have the contract instance. so that we can talk to our smart contract. Okay, and contract, if you will see, by creating this state object, it actually made my work very easy. I have to just use the state object whenever I want in order to interact with my smart contract, and I can use it anywhere, wherever I want, right? So now what I will do is again await contract, and then we will have the methods part, right? This is the same. Then I want to call the setter function, right, in order to set the value of this a variable. And inside this, for now, let us have a hard coded value 10, but definitely we are going to make it a dynamic kind of value. But for now, let us 10 here. And now, instead of having a call function like this, we will have a send function. Now, let me tell you the difference between this call function and this send function. See, whenever you are reading data from blockchain, remember, whenever you are reading data from blockchain, in that case, you are going to use this call function. When you are writing some data on blockchain, in that case, you are going to use this send function. So remember this point, whenever you are reading from blockchain, then dot call. When you are writing on blockchain, then dot send. Okay, so remember this thing. And since you are writing on a blockchain, as I told you before as well, that whenever you are going to make some changes on a blockchain, you need to tell like from which account these changes are happening, right? These changes are actually happening. And since we are using Ganache, we are not using a test network here. What I can do is I can simply provide the from field, like which account is doing this transaction. So let me go to Ganache account section, and then I will copy this down. Okay. So now I have copied this down here. I will simply paste it. So now this account will be doing this setter transaction. Why? Let me tell you why. Because we are actually changing some data on blockchain, so we need to have an account, right? I told you this, right? So now what I can do, I can simply once this data is set, what I will do is I will refresh the page. So window dot location dot reload, and definitely in order to call this particular write data function, I need to create one button. Again, I will be using the CSS afterwards. For now, I'm just creating one button, and on the on click event, I will call this write data function, and let me have the change data button. So let's see whether this is working or not, and then we will add some dynamic value inside this setter function. Let me save this. Okay, everything is correct. These are some warnings. You can work it out afterwards. There is no problem in it. So now we have this change data button. Let me refresh it for now. Close this down. Now I'm calling this change data button, like I'm clicking on this change data button, and as soon as I will click on this change data button, our setter function will get called, means our write data function will get called, which eventually will call the setter data function, like setter function from our smart contract. So I'm calling this, and hooray. So you can see that as soon as I have clicked on this change data button, what actually happened behind the scene, this got called, and once this got called, it actually set the value of our state variable a, and then we reloaded this page. And once we reloaded this page, this use effect again got like this use effect again got into work, means this use effect got re-executed. And once this this use effect got re-executed, it called this again getter function of this contract. And now when it called this getter function from the of this contract, the data it received was the data is actually received was 10, right? That's why we have this data set as 10. Simple process, easy process. It's so easy, right? You can simply read and write data from blockchain. Like it's so simple process, but I do not know why people think that it is a very complicated process, but it's a very simple process, right? Now it's time to have some manual data here. So how we can do that? So in order to have some manual data, I need to have this input text, right? Input type text, and let me have some ID by the name of value. And now what I will do is I will simply use this value by doing this document dot query selector, then double tag, double quotes, right? And then hash, and then we will have the value, and we will fetch the value. Again, I'm using the DOM manipulation of JavaScript here. And then what I will do is I will simply have this data here. So now what I'm trying to do here is whatever user is going to have in this input data field, and when I'm going to call this, button, this input data field value will be getting set in this setter function, because we are fetching the value from this input data field by having this ID, right? By doing this. Now this will contain the data, and then we are going to set this data by using this setter function of our smart contract. Let us check this, and let's go back. We will improve the CSS. I know it's look very bad, but now let us see. Let's say I have 20 here. I'm calling change data, and hooray! So our decentralized application is totally ready. I can change the data, whatever data I want, whenever I want, and then bang. So this is how we have simply created a decentralized application which performs read as well as write operation. And in this, we have used Truffle as well as React.js code. Now it's time to improve this code, and how we will improve this code by having some CSS. So meet you soon by having the CSS part. Okay, so now our CSS part is ready. I have pasted the CSS code here. You can copy paste it from the GitHub link. And here you can see this is our CSS class name. So I have added the class name. So only thing that I have done here is I have added the class name so that it can fetch the CSS part, right? Okay, the selectors and everything. And now if we will go back to our Chrome browser, this is looking great. So this is our first decentralized application, and this is looking delicious, right? Isn't it? Do let me know whether it is looking delicious or not in the comment section. So now let me have some changes in it. Let me do this. Let's see. And hooray, wonderful. So this is how we have completed our Truffle course with this particular decentralized application. How you like this course, let me know in the comment section of this video.